So now, how far have we got? Talking too much, aren't I? Right. Okay, shoot 5 drops in. Let's give her 5,000, a shot of 5,000. Sounds big, doesn't it? Okay. So remember, this is drops, not squirts. So we put this in a 30 ml bottle, okay? Because this will last almost forever, okay? 5 drops, okay? So we're going to use piriformis because that was the weakest of the week. Push your foot in towards Jill. Now, okay, give her another 5. We should really do it one at a time, but I suspect she's pretty bad. 10. So she's up to 10,000. Push your foot into Jill. Okay. Give her another 5. Okay. Push. Nah, not even a glimmer. But we know it's there because the marker for the Smart D strengthened her. So don't despair. Just keep going. 20. Okay. Push in. Nah. Okay. Keep going. Another 5. 25. So she's up to 25,000 now, but remember she gets 20 on a summer's day, so she's not into the high realms. You've got to get into several 100,000. Push in. Now you're another 5. That's up to 30 now. It's got to be a really good summer's day now. Push in. Now she's rock solid. Okay. Now we'll test the glute. Here's up. Push out. Good. Now we're getting somewhere. Okay. So is that, can you give me the D now, the Smart D? So I'll put the Smart D marker back on her, go back into her umbilicus and her circulation sex. Okay. Now I'll go back and see whether that's, should be nice and strong, shouldn't it? Pull. Okay. Now is that all she needs for hypoxia? Okay. How do I test? Take her up and down again. Okay. So I go through each of the eye positions again to see if she needs something else. So I'm doing the same one, pull. So she's okay up and down, she doesn't go weak again. If she'd gone back into weakness, it would have meant that she needed something else, or a bit more. Okay? So let's take her now into the nutrition position. So I'm going round in reverse. Okay. So there is a sequence. You notice what I did first time is I did cranial first, infection. Okay, that was the sequence of it. Allergy, toxin, dehydration, structure, nutrition, hypoxia. Okay? Now remember, this is an emotional problem. Okay, because she strengthened to going down. The whole sequence is round in reverse. You notice that? The most important thing is the unconscious mind, isn't it? That's the cause of it. And what does that cause? It causes problems in the hypoxia, because it affects the brain chemistry, the mind there, which then in turn causes a nutritional deficiency. And because of the changes in the muscle, you get the structural changes, you know, with that. And then you gradually, the system doesn't work properly, so you get the toxins, or you get dehydrated, and then you get the toxins. So you're actually working in reverse. So this is why dehydration is in fact more important than the toxin, if you work the other way around. But if you start from the end result, the phenotype, so the phenotype is, I've got an infection, you know, help me. That's not the problem, is it? The infection is the result of the problem. So you've got to treat that because you can't get it deeper in. So you start with what is the most pressing thing, which is an infection. And you may get along, and then you may need to adjust the neck or something, okay? Because that's very important. And then you find they're zinc deficient, and then you find something else. So if you work from the cause back, you'll see why it is they got the infection. Okay, but you still got to treat the infection. But that's not the cause of their problem. You do not get an infection, you know, unless you're spat at and touched in West Africa. Okay, now, there's something very, very interesting about that. I don't know how many of you take Dr. McCullough's newsletters, but he did an article on the trying to produce a vaccine. And have indemnity, the pharmaceutical companies, because they're speeding this through, and they're worried that if they speed it through, they may actually cause problems because it's hastened through and could cause Ebola, as occurred with the influenza vaccine of 2007. It actually made people predisposed to it. But they think, it's postulated if you go back on his website, it was last week, that there's an element which is deficient in West Africa, which they think is the cause of the hemorrhaging. A selenoprotein, that the people are deficient in selenium. Now, the worst cases of Ebola have been in Zaire. It's almost 90% death rate in Zaire, but it's not there at the moment. It's in West Africa, which has got 50%. Now in East Africa, where they have Ebola from time to time, 90% survival. Okay? And they think it might be to do with the selenium in the soils there, that the people are deficient, because there's a selenoprotein which is active for stopping hemorrhaging. Okay? Now one of the best, people ask us, what do you suggest, for Ebola? I don't know. We haven't had a case of Ebola, and I don't want a case of Ebola coming to see me to say what can you prescribe. So with that in mind, and testing around on many, many infections, one of the best things is black walnut tincture. Now black walnut tincture is marvellous because it's full of iodine, it's full of manganese, all good things for the thyroid gland that we know. But guess what else it's full of? Selenium. I never knew that. Go on the web and you'll see of the elements it's rich in selenium. No wonder that thing, and it shows selenium inhibits viral replication. It's been known for years, this. And you've got to give a good medicinal dose of it to stop a virus from replicating, and that's what they really want in West Africa, is to stop that virus from replicating. Okay? So you go back, if you go take Mercola's website, or I would do it anyway because there's such useful information that comes through every couple of days. But it was in last week, I think it was, about the Ebola virus and the vaccine. It's in that this mineral that they postulate may be the cause of why because people with Ebola die from the hemorrhaging, and that's also when they're most infectious and the most contagious, is when they're dead. Sorry about that. That's not when they're most vitamin D deficient. Okay, where did we get to? Right, so we were going backwards. Okay, so we did, I think, nutrition. Oh, okay, good. Pull. Okay, so we'll just go back to toxins. Back, follow. When they don't follow your finger, you know they're thinking of something else. Pull, or they don't pull. Okay, down. So we do structure. Okay, pull. Okay, we'll do allergy on route. Back. It's habituation. We'll even do straight across to the right. That's for exercise, which we don't normally do at the beginning. Okay, up. Okay, dehydration. Round and round, just finally check. Because sometimes they show up, a bit further down. When you go round again, they show an infection. Sometimes the cranial foot only comes out when you do it, twice round. So breathe in. Hold it, pull, and breathe out. Hold it, pull. Right, so she's clear except for one position. There's one position I haven't done yet, okay? And that's side to side. I call this the windscreen wipers. So here to here. You've got to have long arms for this. Here to here, okay? This is ATP. The ultimate challenge is, has she got enough ATP? Pull. So close she was to there. Okay. And we know it's not vitamin D. Okay, she's got vitamin D on her, okay, but she's failed. Pull, the last hurdle. She's got no energy in the mitochondria. Okay, what could be causing this? Toxin, perhaps, yes. We'll come on to it later on. All the text is in your manual, but I'm more or less talking about it now. The one thing that stimulates the breakdown of the mitochondria and inhibition of ATP is hypoxia. Hypoxia means lack of oxygen, and what this does is actually stimulates the production of free radicals or reactive oxygen species, which further damage. Now, the mitochondria, as we'll see, is a wonderful place of powerhouse. It produces 36 or so molecules of ATP, as opposed to glycolysis, which only produces 4. Okay, so that's a very inefficient. And the theory is, and this is only a theory, is that many, many billions of years ago, simple bacteria in the earth were breathing methane gas from volcanoes. The atmosphere in the earth was methane, and when simplest life developed from here, they were bacteria which were anaerobic methane breathers. And then some bacteria were able to breathe oxygen as oxygen increased with the production of plants and things like that. Eventually, you got this crossover of the methane gas in the air and oxygen, and at that point, the aerobic oxygen breathers invaded the anaerobes, and that became the mitochondria. So the mitochondria is actually an anaerobic bacteria inside your cells. It has its own DNA, its own structure. It lives inside the cell, and it works anaerobic. Thank heaven, otherwise we would all working around aerobically, very long and suffering. And this is a wonderful because it gives us our ability to have energy. Okay? Now, there's times when we don't want that energy, though. We want to rest. We want to go into a dormant or sleeping repair stage, as it's called, and that's the glycolysis. And there's a switch. So we can switch from being aerobic to anaerobic and back again. So when you've had a tissue injury, you don't want to be working out aerobically, because at that point you'll produce a lot of free radicals, and that will increase the damage. So if we switch to the glycolysis or anaerobe, that's the time when you repair tissue. But it stimulates cell division. So when you have cell division, you could get a malignancy. Okay, so you know that all malignancies are anaerobic. There's hypoxia inside there, the lack of oxygen, but this is a switch, and it's a protective switch in complex 4, as which we'll have a look, of the mitochondria. So it's flicked, and that turns you into being anaerobic. And a lot of our patients are anaerobic. They simply just, are hypoxic, and they can't produce energy. They fail like Sue does. She fails completely on energy. So let's just see how bad she is, shall we? Okay. Okay, how bad, on a scale of 1 to 10, let's say, let's take everything off there. On a scale of 1 to 10, okay, with 10 being the best you've ever been in your life, okay, ever been in your life, right now, where would you say you were, with 1 being the worst and 10 being the best? And health being all-encompassing, in other words, emotional, biochemical, mechanical, everything.
6.
6, okay? So let's just extend that out, and we'll say 100 being 100% is the best you've ever been. Okay? Yeah. So now we'll do a subconscious. So I'm going to ask her a statement, and she's going to answer with her left muscle in a subconscious way. In other words, on, off. And she's going to listen to the question, but she's not going to answer it because the subconscious is not verbal. It's non-verbal. So we'll see what subconscious says. So on a scale of 1 to 100, 100 being the best you've ever been, okay? Right now, your scale of health calibrates at 60% or 60 or higher. Pull. At 50 or higher. Pull. At 55 or higher. Pull. At 50 or higher. So she's a little bit optimistic. Okay? She's actually only 50%. Okay? So she's firing on 2 cylinders instead of 4. All right? So now, let's change the question. Or the statement. Let's say if 100 is the best you could be, in other words, your potential for your genetic expression, because she may never have been good. She's been good for her, and most people will say, well, when do you think you calibrated at 100% for you? How old?
At how old?
When were you at your best, your peak? If you're only 50% now...
16.
16. So that was a good time, wasn't it? Don't you wish you were back there sometimes? Or you made more of that time. You could have had a whale of a time thinking, this is the best times of my life. I'm going to make them really live it. Okay. So let's say 100. All right, same challenge. But this time 100 is the best you could be. Okay, in other words, your genetic potential. The best you possibly could be. Right now, out of 100, you calibrate at 50% or higher. Pull. At 55% or higher, pull. At 50 or higher, pull. So when she was 16, she was at her best, genetically and phenotype. In other words, that was the best you can get. Sorry about that, but if 16 was great years, you'd be happy to get back to that, wouldn't you? Or how you felt then. So that is the best you can do. Right? Do you see the difference in the 2 questions? There's 2 statements. Okay? One is what are you now in comparison to when you were your best, and the other one is what are you in potential. There was, because some people may never have been there. They could always have had bad food in the diet, always been in a bad environment, a lot of stress and so on. So they may never have reached their 100%. So we know there's something else. So shall we bring the D back on there, and let's pop her back into here. So what do we do here? Yeah. So we're going to use the CO. No, take that away a moment. Okay, CO and CN. Now, what you'll find is in a hypoxic state, we stimulate an enzyme called heme oxygenase in the mitochondria, which starts to oxidize heme, which is a component of hemoglobin, but it's also a component of the substances in the mitochondria called cytochrome C. So we start to blow up the apparatus. Okay? Getting familiar with what we're talking about with the nuclear reaction going on. Okay? Now, the byproduct of the breakdown of heme is bilirubin and biliverdin. You know, if you get a bruise, if you stick your arm out here a minute and I'll... okay. And you go blue, don't you? And then you go yellow. And that's the difference between bilirubin and biliverdin. Okay? So you start to make these. But the byproduct of this in there is carbon monoxide. Carbon monoxide is produced in the mitochondria. You might as well stick your head in the exhaust pipe of your car. Okay? This is highly carcinogenic and stimulates the cell division process. In other words, the mitochondria switches off. So it's a failsafe, it's a switch. Okay? So we now switch from being aerobic to anaerobic, which happens with all cancers. So living in a toxic environment with lots of carbon monoxide may not be a good idea. Okay? May not be the cause of the cancer, but it stimulates cell division. Now this is really interesting because carbon monoxide is produced, or, as the books tell us, in severe hypoxia, cyanide is produced. Cyanide is CN. Carbon monoxide is CO. Okay? Both of them pretty nasty, but I'd go for cyanide being the worst of the two. Okay? So let's test her because her mitochondria are in trouble. And that's what the ATP test does. It's not like an energy, because we know we've been through nutrition, we know we've been through hypoxia. So if it had been magnesium she needed, it would have shown up already, wouldn't it? But this is only done this. This means that her mitochondria is not working properly. Now, when I was a child, my parents had a boiler in the kitchen. And we used to, or Mum used to do it, and then as we got older, you had to riddle the boiler because it was coke. You remember, you had to riddle it because otherwise you get a build up of clinker in the bottom of the boiler, and then there's not enough air gets in there to get the flames to go up, and then you get a cold bath. Mind you, we only had a bath once a week, so it didn't matter so much. Did you have a bath once a week? Once a week, that's right. Yeah, Saturday night. Oh, this is big Saturday night. Okay. So you had to riddle the boiler and the clinker. And this is really what we want to do with Sue, is we want to riddle her boiler or get rid of some of her clinker. She's getting clinker in the furnace. Okay. Now let's see what gases she's emitting, not admitting, emitting. So let's try carbon monoxide. Carbon monoxide, CO. Okay. You've all got this in your pack, I think. Okay. Paul. Okay. So CN is cyanide. Okay? Don't let the patient panic at this. You say this is perfectly normal. We all produce a little bit of cyanide because they think they're eating it or someone's poisoning them. Paul. Oh dear, her hypoxia is worse than what we thought. So she's got the CN. So about 50% of people who weaken to the ATP are cyanide and the other 50% are carbon monoxide. I haven't yet found someone who does the two. Okay? So, but you're one or the other. But we know the answers, so don't worry about that. We're going to just bridge the gap between complex 3 and 4 and basically rebuild your cytochrome pathway. And we'll look at that in detail with the overheads and things. But before we get there and know the answer, we want to just do something really quite miraculous. So we need those little acetates. Bob, have you got the acetates? You know the acetates that you're doing? If Jill, you bring out those. Now, something I learned 20 years ago when I first did interesting topics of teaching away from just the basic AK, I did a seminar on detoxification. And one of the things I learned from Harper's Biochemistry in those days that there's two phases, what's called phase 1 and phase 2. And phase 1 is called phase 1 detoxification and is mediated by a series of enzymes called cytochrome P450, okay? Or mixed functional oxidase enzymes. In other words, they actually add an OH to the substance to make it more water soluble, okay? And then phase 2 was methylation or conjugation to make it even more water soluble so the body could pass out the toxin. So most drugs and most xenobiotics, in other words, things that are strange to the body, not normal substances that we use, have to go through phase 1 and phase 2. Water-soluble toxins may just pass straight through. You know, that's not an issue. But those that are fat-soluble, which are like pesticides and herbicides and all these things, have to go through phase 1 and phase 2. Some years ago, they found that 30%, third of people that they tested their urine showed two pesticides in their urine. That was the good news. The bad news was the other 2/3 who didn't show it, because it meant they were storing it. Okay? And that's what fooled everybody's worried, but a third of people got pesticide toxicity. It was the other 2/3 who were the real problem, okay? Which meant they weren't going through phase 1 or phase 2, okay? Now, one of the things I learned is that this cytochrome P450 was a particular enzyme which is heme-based. It's a heme. You remember we did heme in the update and in the summer in hemoglobin to do with hypoxia. So it's based on how we produce hemoglobin. It's the heme component of that. So that's an important part. It was also very much dependent upon phosphatidylcholine, etc., etc. But the key took me 20 years before, and sometimes I'm a bit slow in learning these things, and I woke up the other night and somebody was sort of irritating my brain, and it does that sometimes, and knocking on there saying, cytochrome P450, this is 1 o'clock in the morning or 3 o'clock or something, well, cytochrome P450, cytochrome P450, Christopher! And I thought, why am I thinking of cytochrome P450? And it kept on saying it. P450, 450, 450. And I thought, go back to the book. Cytochrome P450 exhibits a wavelength of 450 nanometers. Okay, that's why it's called cytochrome P450 on chromatography. But on one condition, when it's exposed to carbon monoxide. Okay? When it's exposed to carbon monoxide, it emits on the chromatography this wavelength of 450. Isn't that interesting? That's why it's called cytochrome P450. And I've known that for 20 years and never thought, I can make P450, I can make 450 nanometers. Okay? Because we don't know how to make different colors and things. So let's get the 450. So you should find there. So 450 is carbon monoxide. This is cytochrome P450. It's a lovely blue range there. So we'll just pop that on her eyes so she goes a little bit through there. Okay? So this, remember, she doesn't show the carbon monoxide. Pull. But this is, if she weakens to this, she'll weaken to the carbon monoxide and vice versa. Okay? Now, say you have severe hypoxia and your heme oxygenase doesn't produce carbon monoxide but produces cyanide instead. Okay? What happens to the cytochrome? Cytochrome P450 takes it up. Okay? But it's no longer exhibiting 450 because it's not with carbon monoxide, it's with CN. It changes the wavelength that it exhibits. It reduces it down to 430. 430 is blue, but in the slightly more violet range. Okay, it's got a bit of red in it. So this, when you look at the two, you won't really see too much difference. It's 20 nanometers, but that's an enormous amount in electromagnetics. Okay? So you look at those and say, well, actually they look the same. They're not the same. Okay? This is 430. So remember, she's got nothing else on her. Okay? 430. Pull. Come on, pull. Pull. She's just got nothing at all. Just use any strong muscle. Push out to the side. Absolutely as weak as a kitten. You wouldn't believe that, would you? With 430. Okay? 450, she was no problem at all. Okay? 430, weak as a kitten. Okay? Now, that gives us a lovely marker. Now, if we take that off, now you know with doing the colours with the acetates, the constitutional colours, okay, that for every colour, there's a complementary colour. Okay? An equal and opposite. So if you took that 430, in her case, out, and added all the other colours together, you'd end up with a complementary colour. Now, what colour do you think that is? Some say orange. What colour is it? 430, is that it? It's going to be yellow-green, okay? So remember, if you do a circle, draw a big circle in your mind, divide it into 3, okay? So 1/3 is going to be reds and orange, the second third will be yellows and greens, and the third will be blues, violets and indigos, okay? So those are the 3 prime colours, okay? So if you have a problem with blue, say the complement to blue would be red and green, which would give you turquoise, okay? So if you move more around to the violet range, which you're doing out of the blue, at 430, you're coming in more from the yellow into the green area. So this is why this is. Now, let's give her this colour, okay? This is the way. And this, you can say, oh, yeah. Okay, let's pop that one on. So if you give me the cyanide So let's do it with the cyanide. This will just confirm to you that this will negate the cyanide. Have I got it? There we are. So let's just take her back now with the cyanide on her, all right? So she's going to poison herself. Now, let's put the green on her. Can you just tilt your head a bit forward? That's it. Good. Okay. Pull. Isn't that interesting? She's as weak as a kitten, but with that colour, she's suddenly strong. What's happening? Because we can put this anywhere. There's a lot more to light, isn't there, and wavelengths than what we imagine. And this is what that cell symbiosis, which you can read the text in, is all about. The DNA, or the energy, the ATP produced in the mitochondria, is a messenger. It sends signals, or it's a message. There's an electromagnetic message coming out of your very cells, and she's saying, "Help!" is my message. I'm being poisoned with cyanide. Okay, and what's the answer? Obviously, we've got to get rid of the cyanide. We've got to get to the cause of the cyanide, and so on. So this will heal her, but if we put it underneath her skin there, pull. It makes no difference. It has to have the light to come through it. So the light has a frequency or a wavelength, okay? As does everything. Everything has a wavelength. So this is what quantum mechanics is about. Sometimes things are waves and sometimes they're particles, all right? So we're going to do the same thing. We're going to use cyanide as a wave or as a particle, all right? So both are the same. They're just different sides of the coin, all right? So now what we need to do is find out what we'll get here. So if we put the vitamin D back on her, well, just to show you how powerful this is, pop that back on. Okay, let's tie her muscles. Push out. Push your foot in. So, isn't that wonderful? Just that one colour will strengthen everything, right? Does she still need the D? Of course she does, because she can't get the D to work, okay? So she's got to take the D to get the enzymes to work. But we've still if we put the D back on her, we're still left with this ATP problem. Okay, so where is it? Lesson 6. So she's in strength with the D, pull, and then we're taking the ATP, windscreen wipers, pull. Okay, now to bridge the gap there, to regenerate the cytochrome C in there, we need what's called a polyphenolic. A polyphenolic is a plant substance, like a vitamin, that the body can't make, but has to get from the food. And the one that they found is the best one here, although there's lots of them. You remember back in the summertime we introduced about lutein being a complementary colour to the mauve, is turmeric. So we want, first of all, no we don't. I could never get turmeric to work. All this stuff about turmeric, wonderful for Alzheimer's disease, wonderful for this, yeah. And I could never get it to work. And I thought, how come? And I made one cardinal mistake, which I learned from cell symbiosis, is I used turmeric from the shop, okay, which was not organic, okay. Turmeric is sprayed like mad, okay. If you have inorganic spices, you're going to poison yourself. Never, never, never use turmeric or ginger or cinnamon, which is not organic. It won't work, okay. In fact, people weaken most of the time to it. I don't think we've got any non-organic here, otherwise I would have shown you. But what they say on the websites now, only 2-3 weeks ago, across the newspapers, was eating curries and turmeric may ward off Alzheimer's disease, blah, 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 blah. And then you read finally at the bottom, well, this was done in mice. And German researchers have found this. Then you go to Medline and you find the actual real paper there, and on the Alzheimer's Society, and they say there are termerones and substances within turmeric which have been shown to actually stimulate stem cell growth in the brain. This is true. But you would have to eat so much turmeric you would get gut problems, okay? So you'd have to have 3-4 teaspoons of this stuff a day to possibly get the active ingredients, because you only absorb about 10%. So the answer was, how do you improve the absorption? The answer was piperin again, okay? But not piperin from black pepper. And as somebody else said, you shouldn't really use black pepper that much because it's full of molds as well, isn't it? It's a very high source of molds, black pepper. Okay, but our friend black cumin seed is beautiful. Now, whether it's the piperine in the black cumin seed, I don't know, but it works like joy. You know, it's fantastic stuff. So now we make a smart, give me the smart turmeric. All right, remember she's in weakness. She's got her vitamin D on her still here. I'll move that along there. Hopefully she's still in weakness. Pull. Okay, so let's pop on the turmeric. Now start with 1. Pull. 2. Another 1. 3. Pull. Okay, now is that going to be enough for her? Let's see. So we know she strengthens to that. Let's go back to our muscles. So we take the D off, push out, strengthens the gluteus medius up. Okay, push the foot in, it strengthens her up very nicely there. Now, how often should she take that? Once a day, twice a day, 3 times a day, every hour? Okay, so let's go on, just cross-check with the body clock again. Okay, stomach, that's breakfast time, isn't it? So let's test the weak muscle and see if she stays strong. Push. So she stays strong at stomach time, so that's a good time to take it. Okay. Let's pop her on circulation sex time. Okay, that's her dinner time, isn't it? 7 till 9. Okay, push in. So she stays strong there. And let's go to 1 o'clock till 3 o'clock small intestine time, which is lunchtime. Push. Okay, let's go to heart time. That was 11 o'clock till 1. Mid-morning snack time. Push. There. Okay. Take her up to, say, liver time. Go to the middle of the night for her. Okay. Push. There. Okay, so she needs it 3 times a day at the meals. Always take turmeric with meals. Don't take it on an empty stomach. It sits there. But she needs, 3 capsules 3 times a day. And she needs, what was the other, 30 drops, was it, of vitamin D. Okay. So now we do both things back on again. So put the D. Yeah, whichever. Yeah, either the marker or that one. Okay. Pull. Pull. Okay, so we go one. Just go back in your tummy button there. That's it, and back onto here. Okay, so pull. Just give her the windscreen wipers again, just to make double sure. Now, the best way of making finally sure that there's nothing else is just get you to close your eyes. Pull, and open your eyes. Pull. Okay, this is sort of like a final check just to make sure there's nothing else. So the 2 things she needs desperately, which strengthen, both of them strengthen up her muscles a trade, is she needs vitamin D, but in the activated form with the black cumin seed. Just to show you, could you get some black cumin seed out? Just to show you it's not the black cumin seed that she needs. If you give me the oil from the oil kit. Okay, because people say, well, surely on that basis it's the black cumin seed that I need. It's not. There's something in black cumin that activates the D and helps the absorption of the turmeric. So, pull. So you can see black cumin seed doesn't do anything. Okay, it's not the black cumin seed that she needs. It's the black cumin activates or stimulates something to get the D to work better. Okay, now one just last thing before we break, and then you can have your hot potato. Okay, now her main muscle is the piriformis, I think. All right. Now we found that it's weak. All right, and there will be in there a physical manifestation of her emotion. Okay. Now the piriformis is a circulation sex, and what emotion is that?
It's courage and affirmation.
Courage and affirmation in her life. This is the unconscious emotion that she needs to bring forward, or to bring more of that out into her. Now, what she's going to do is she's going to touch there. Stick your fingers there, take that one off, exactly where my finger is. Okay? So I'm going right into the piriformis muscle, into the belly of it. All right? Push the foot in, and she strengthens when she TLs the belly of the muscle. All right? Over onto your front. Go over on your front, yeah. There's nothing there now. Okay. So, we have got a trigger point. Okay? And the trigger point is in the belly. Wait, listen to her. Oh, all right? It is as painful as hell. All right? That means you got it. This is where her unconscious emotion somatically is manifesting, all right? So we have to get rid of this trigger point in her, all right? And she will feel wonderful afterwards, okay? So, trigger point therapy number 1, position 1, is 15 seconds pumping into it. You can do this any way you want. Chiropractors often use a thing called a T-bar, which is a wooden bar with a rubber bit on the end. So you count 15 seconds. The patient will do that for you. It's a long 15 seconds. And then it's not painful, and then you push upwards 15 seconds and pump it 15 seconds. The whole process only takes just over a minute, but it's a long minute. No problem to your elbow, but boy oh boy. And then 15 seconds inwards. So you're going through the sort of 4 positions, north, south, east and west. Do you understand? Can you see what I'm doing? Or has Gary got that up on the screen? Come on, let's hear some noise. She's got a gag in her mouth. And now 15 seconds downwards. Ooh, one of them's usually much more painful than the other ones. It's difficult to tell which one it is. And then 15 seconds outwards. That's painful. Oh, God. It's usually when the first swear word comes in, you know that you got the painful one.
So you pump with your elbow?
Yes. No, I'm just... No, this one's just resting. I've got to put it somewhere, so I put it on. No, all the work is here, you know. So it's just coming through on that, down, like a pump, and then 15 seconds up, across. So it doesn't matter where you do it. You know, you can do it with your fingertips. But for this one, the elbow is the best. You simply will mess up your thumb if you try and do it with your thumb. You can't get in deep enough. Go over onto your back. Now you'll see the wonder of that and why the emotion is the key bit. Can we get the cyanides and things out? Okay, so let's have a look at the gluteus medius. Okay, this is the other muscle. Push out. It's gone strong. Okay, piriformis, push in. Beautiful. Okay, cyanide on her. Pull. She's strong to cyanide. Let's put her on here. All the markers we've got have gone. Okay? That's because you release the emotional bit. And she'll feel pull. She'll either burst out into tears before lunch or she'll laugh and things because she'll feel so good because she'll get a release. Maybe nothing will happen, okay? But she will say, actually, I feel a lot better. Okay? So you release that core of where it goes, and the subconscious, the unconscious emotion goes into the somatic system through the muscles. Okay? But the question is which muscle, and it is the one that's associated with the drop in the energy. That's how the problems develop. So all the symptoms she's told us about, aches and pains, and tell us a bit more about your symptoms.
Just tightness in the joints.
Tight.
Yeah, and in the shoulder, and just generally feeling restricted.
Restricted, yeah. What, in your life as well? That's a good point, isn't it? Mm-hmm. What was the emotion?
Courage.
An affirmation. Affirmation, yeah. She feels restricted in her life. She said, I feel restricted, but that's a manifestation of her mind, isn't it? Her physical restriction is because her mind is restricted. Keep going. More symptoms. Tiredness.
Symptoms. Sorry?
Tiredness, yes.
Um,
Memory.
Occasionally, yes. When I'm feeling low, the memory is...
Okay. Vision.
Vision is poor.
Yeah.
It's weakening.
It's weakening. Okay, see how it's building out. You're getting a bigger story now, haven't you? That's why she stuck her hand up. She wanted to be tested. That's why she stuck her hand up. And now she knows she was only 50%. It's a good job. She stuck her hand up because she's 50%. Okay, she needs a lot of vitamin D. 30,000 international units. 30,000? Yes, 30,000 international units. But you know, remember that 20,000 is the summer's day, so it's not desperately high. And she needs turmeric to restore her mitochondria, to get that oxygenation back in there, deep in the heart of the mitochondria, to stop that ATP clinker building up. Okay, but I'll describe that in a bit more detail after lunch. Okay, so do you think you can do all that on each other over lunchtime? While the rest of us are going to have baked potato, you can do it. You think it's easy, the procedure. The procedure is all written down on there. It's quite easy. Find your meridians, go around the eyes to find out which is the key ones there, and hit them each one that comes up positive, treat accordingly, and then find the trigger point in the weak muscle, identify the muscle, do the trigger point, but do that last, because once you've done it, you've lost all your markers. Okay?